process begins with scrap steel, which has been selected and sorted to meet our customers' requirements and to maximize the efficiency of the melting process. The scrap metal is charged into the electric arc furnace, where high-powered energy is delivered through electrodes that are aided by oxy-fuel burners that quickly bring the scrap to molten temperature. Here the liquid steel is refined with bulk alloy additions that are stirred into the steel bath using the activity caused from the chemical reactions of the melting process. The liquid steel is then tapped into a ladle and covered with an engineered synthetic slag to prevent oxidation. At the ladle refining station, further alloy additions are made to bring the steel chemistry close to customer specification for alloy content and DI requirements. Argon stirring occurs throughout the process to ensure homogenization of the alloys and to facilitate the absorption of non-metallic inclusions into the synthetic fluxes. The final process in refining is to apply vacuum pressure to the liquid steel at the vacuum degassing station. The vacuum aids in the diffusion of undesirable hydrogen and nitrogen gases into the fluxes. The final trim alloy additions are made here to achieve the optimal chemistry for the customer application. The liquid steel is now ready for solidification, which occurs in the casting process. The ladle is delivered to either the continuous rotary caster or strand caster, where the steel is converted into solid billets and blooms. At the rotary continuous caster, a ceramic shroud is installed at the bottom of the ladle to feed the liquid steel into the specially designed tun dish, preventing exposure to oxygen and allowing time for the flotation of non-metallic inclusions into the fluxes. The tun dish feeds the liquid steel to the rotating caster molds through a pouring reel. The centrifugal force of the rotating mold forces the steel to the caster mold wall for instant solidification of the billet surface. Stopper rods installed at the bottom of the tun dish automatically control the flow of steel in the caster mold. This eliminates fluctuation of the mold level and ensures consistent quality. The solidifying billet continues rotating as it passes through the water spray zones, allowing for even cooling of the billet, giving the billet uniform properties from center to edge with minimal distortion. Once the bars are at the required length, the hot saws cut the billet and the tilting mechanism delivers the billet to the next process. Gerdau's strand casting begins as liquid steel enters the tun dish through a fully submerged ceramic shroud, protected by argon gas to prevent oxidation. A specially engineered slag detection process prevents any carryover of slag from the ladle into the tun dish. The tun dish is engineered to prevent contaminants from entering the strand casting mold. Gamma radiation detection is utilized to continuously monitor mold level and automatically make adjustments. Electromagnetic stirring occurs just below the mold, which creates a uniform heat transfer, resulting in a billet leaving the mold ready to be cooled through the controlled water spray zones. The solidified billet from our rotary or strand caster is now ready for rolling at one of Gerdau's bar mills. Billets then enter the walking beam reheat furnace to reach the ideal rolling temperature. Descaling of the billet surface occurs as it exits the furnace and prior to rolling. Gerdau's special steel rolling mills produce bars from 5/8 of an inch to 6 inches in diameter. Each of Gerdau's bar mills are equipped with precision rolling stands to produce tight size tolerances, uniform weight, and a concentric round surface. Bar length is controlled through the use of hot abrasive or carbide-tipped saws. Automatic chamfering is available on large diameter bars. The hot-rolled bars are then tightly bundled for shipment to the customer or further on-site value-added processing. Inline bar straightening, surface, and ultrasonic internal inspection is available at all Gerdau SBQ mills, ensuring stringent customer specifications are met. Other on-site finishing solutions include thermal treating with a complete range of in-house normalizing, annealing, and customized treating processes. Gerdau's SBQ mills are equipped to produce MAC Plus cold finish bars, which are turned and polished to a bright and smooth finish, fit for cold or warm forming and other critical applications that need precise weight control, close dimensions, and enhanced machinability. Another in-house solution is MAC Prime, precise first operation blanks, which are cut on high-speed equipment with additional processes such as automatic inspection of all dimensions, end chamfering, face in centering, straightening, and special packaging.